forming ionic compounds with polyatomic ions. So just like we did in the last worksheet where we were making a compound out of the name, we're going to do the same thing again here, but in this case we're going to have polyatomic ions. So you'll need your polyatomic ion sheet that has the names and the charges of the different polyatomic ions. And you're also going to need your periodic table. So let's look at a couple of examples from your reading materials. This is the Forming Ionic Compounds worksheet in your reading. And you can see down here at the bottom, it says with polyatomic ions, the only difference when we add in polyatomic ions is that if we need more than one polyatomic ion, we must put it in parentheses. So here's an example. Calcium hydroxide. Calcium, we look up on the periodic table. It's in group 2, so it has a +2 charge, so +2. OH is hydroxide. All right, we look up hydroxide right here. It's OH, and it has a -1 charge. So OH with a -1 charge. Because they don't add up to 0, we do have to use the crisscross method. We don't write 1s, so we're just going to bring this 2 down for OH. When we do that, we need to make sure that we're saying we have 2 OHs, not just 2 H's. If I put the 2 after H with no parentheses, I'm saying I have 1 O and 2 H's, but that's not the case. I need to have 2 hydroxides because OH as a clump has a charge of -1. So I bring that 2 down, and I'm going to put OH in parentheses and write my 2. Remember, I don't actually write the 1 in the formula, so Ca parentheses OH close parentheses 2. We still read this as CaOH2. Now if we have transition metals like we do at the bottom of our worksheet here, don't forget the only difference is that this tells you the charge of this first element, so I don't have to go look it up on the periodic table. So here's copper, which is a +2. Phosphate is a -3. I looked that up from here. Phosphate, PO4, is -3. PO4 with a -3 charge. And I have +2 and -3 do not add up to 0, so I use the crisscross method, cross my 2 and my 3 over, put my 3 down here as the subscript for Cu, my 2 is the subscript for PO4. I don't change PO4, it stays PO4 because PO4 is phosphate. I put it in parentheses and put a 2 outside of it. So I end up with Cu3, PO4, 2. Let's do a couple of examples so you can see how this works. Here's ammonium phosphate. Now ammonium, remember, is one of the exceptions to the rule that usually you don't have a polyatomic ion at the beginning, but ammonium is one of the few exceptions. So here's ammonium with a +1 charge, NH4 +1. So I would write NH4 +1 charge. Phosphate, we use a lot, PO4 with a -3 charge. PO4, -3 charge. These do not add up to 0, so I'm going to cross them over. Again, I don't have to write 1s, so I'm going to ignore that part, and I bring my 3 down here. Because I need 3 ammoniums, I need 3 NH4s, which means I'll put NH4 in parentheses and then write the 3 afterward. PO4 does not get a subscript because we don't write 1s, so it's just PO4. I don't put it in parentheses because there's nothing that goes after it. If this had been PO4-2, if I needed to bring down a 2 from here, I would have put this in parentheses and then put my 2. Okay, we don't put the polyatomic ion in parentheses unless it gets an extra subscript added on at the end. Then down here, here's iron 2 carbonate. Iron is Fe. This 2 in parentheses tells me it's a +2 charge. Carbonate is on my polyatomic ion chart. It's right here, carbonate, CO3 with a -2 charge. So CO3 with a -2 charge. They already add up to 0, so I just write it out, FeCO3. Again, no parentheses here because I didn't have to cross over any number. If I do have to cross it over, CO3 would go in parentheses. Again, if you still have questions, make sure you ask.